All right, let's get right into it. We're going to pull back the curtain on how the internet actually works. I'm talking about the real physical hardware that takes a click on your screen and zips it across the entire globe.
I mean, you've got to wonder, right? It feels like actual magic. You type something in, and bam, the whole world of information is right there. But, it's not magic. It's this incredible chain of hardware all working in sync. So let's follow that chain, starting right from your desk, and see just how far it goes.
So every journey has to start somewhere. And for any little piece of data leaving your computer, that journey kicks off with one single, absolutely crucial piece of hardware. Think of it like its passport to get out into the network.
And here it is, the Network Interface Controller, or NIC for short. This little guy is basically the gatekeeper. Seriously, without a NIC, your computer is just an island, totally cut off from everything else. It's the part that gives you the physical connection, the plug for the cable or the antenna for Wi-Fi, that lets your device even begin to talk to the rest of the world.
And what's really wild is how common these are now. Back in the day, this was a whole separate card you had to buy and install yourself. Now, it's pretty much always built right into the computer's motherboard. It can handle a physical cable or a Wi-Fi signal, and it uses something called a protocol, which is just a fancy word for a set of rules, to make sure all that communication happens smoothly. Okay, so your computer has its passport. Awesome. But what if you just want to talk to the printer in the next room or send a file to the computer next to you? Well, that's where your local network comes into play. It's all about creating your own little private hub for all your devices. All right, say hello to the switch. This thing is the smart traffic cop for your local network. The mail sorter analogy is perfect. Imagine an office building. The switch doesn't just yell a message down the hallway for everyone to hear. No, it knows exactly which desk, or in our case, which computer, the message is for, and it sends it only there. It's all about making sure local traffic is super efficient.
So, how does it get so smart? Well, it learns, and it learns fast. When a device sends out some data, the switch takes a peek at that data packet. It reads the from address and basically makes a little note to itself, like, okay, that computer's plugged into port number 4. It builds this internal map of every device on the network. So the next time data shows up for that computer, the switch doesn't have to guess at all. It just knows exactly where to send it. No fuss.
Of course, we're not always plugging in cables these days, are we? The wireless version of plugging into a switch is connecting to a wireless access point, or a WAP. This is the device that's broadcasting that Wi-Fi signal that your phone, your laptop, and your tablet are all grabbing onto. It's your ticket to the local network, no strings or cables attached. And this really gets to the heart of the big trade-off, doesn't it? Going wireless is unbelievably convenient. I mean, no cables, you can move around, it's great. But that convenience usually comes with a price. Often you get a bit less bandwidth, and security can be a bigger worry. A wired connection, though, a little less flexible, for sure, but it's generally going to give you better speed, more reliability, and tighter security. All right, so we've got our local network all figured out, but what about the really cool part? What about sending data outside our little bubble, out into a world? To do that, we need a totally different piece of gear, a gateway that can connect our private network to the gigantic public network we call the internet. And that gateway, my friends, is the router. Now, this is the key thing to remember. While a switch connects devices inside a single network, a router's job is to connect different networks to each other. It's the bouncer at the door of your local network, directing any traffic that wants to go out to the wider world, the wide area network, or WAN. Yeah, this is where a lot of people get mixed up, so let's make it super clear. A switch, that's your local neighborhood traffic controller. It works inside one network, your LAN, and it uses the device's physical NIC address. A router, on the other hand, is like an international airport controller. It works between networks, connecting you to the wider internet, and it uses IP addresses, which are kind of like the global postal codes for every device out there. So we've talked about the smart devices that are directing all this traffic, but how does the data actually move? Well, it travels through physical cables that are basically the roads and superhighways of our digital world. Okay, for most of the connections you see every day, like your desktop computer plugged into the wall, you're looking at one of these, a twisted pair copper cable. You and I, we just call it an Ethernet cable. And the reason the wires inside are all twisted up is actually pretty clever. It helps cut down on electrical interference. These things are cheap, they're flexible, and they're just perfect for those shorter distances around the home or office. But when you need to go big, I'm talking connecting cities, connecting continents, you need the big guns. And that's where fiber optic cable comes in. This is a whole different ballgame.
Instead of electricity through copper, this tech shoots pulses of light through hair-thin strands of glass, and that lets it handle an absolutely insane amount of data over huge, huge distances.
So really, it all comes down to using the right tool for the right job. Copper cable? That's your affordable, practical, get-it-done choice for wiring up an office. But fiber optic? That's the high-octane engine that powers the actual backbone of the internet, handling the colossal tsunami of traffic that flows between major cities and countries every single second.
Okay, we've met all the main players. So now, for the grand finale, let's follow one single packet of data on its incredible journey. We're going to trace it from the moment it leaves your screen all the way out into the world and see how all these pieces fit together like a perfect puzzle.
It all kicks off the second you click that link. Your computer's NIC, its passport, remember, packages up that request and sends it on its way, out onto your local network. First stop, the switch. The local traffic cop sees this packet is headed for the great wide open, not for another local device, so it knows exactly where to send it next. And that's the router. The switch hands off the packet to the gateway, which is the official exit ramp from your private network onto the public internet. And then whoosh, the router launches that packet onto the information superhighway, that massive global web of fiber optic cables. It's now zipping across the planet at nearly the speed of light to get wherever it needs to go.
And just think, that whole trip happens in less time than it takes to blink. It's amazing. But it does make you wonder, right? We love the convenience of wireless in our homes. So as that wireless tech gets faster and more powerful, could we ever see a future where those massive physical cables that hold the internet together just disappear? Definitely something to think about.